Okay.
We are live, Kelly.
Hi, everyone. I'm Kaye, Program Manager for the Power BI Community Engagement Lead. Today, we have
Kelly.
Jay Heerdt. Sorry, we have Jay Heerdt here, Program Manager of Power BI, and he's going to talk to us about data modeling and the importance of data modeling. We have some giveaways and some stuff coming up in the Power BI community, so join us now on the Power BI community. Hi, everyone. Welcome and thank you so much for joining us today. It is Monday, the 23rd of May, and my name is Kaye. I'm the Community Engagement Lead for the Power BI community, and we love that you've joined us. Today, we've got a lot to share with you, but if you're here for the first time, please ensure that you go and register at community.powerbi.com and also subscribe to the Power BI YouTube channel for more. Okay, so first up, we're going to tell you a little bit about the Power BI show, which is people coming together who love Power BI, sharing knowledge, and our goal is for you to learn as much as possible, to engage, and to share what you build in Power BI. So here we go. Today we've got a lot of things coming up in the community, don't we now, Daniel? And Daniel is our Power BI community show producer. Hi,
Good
Daniel.
morning, everyone. Hi, good morning. How's everything going? I'm really excited.
Yeah, me too. Daniel's a bit shy, so we always try and give him a bit of a nudge to come up and say hi to everybody. So hi.
Hi. I prefer modest, but anyway, yeah. I'm very excited for today, and looking forward to it.
Yeah. And we're also joined, thank you, and we're also joined by our great community managers, Eileen and Natalie. So you'll see them around in the YouTube chat, but more importantly, you'll see them in the community chat. So if you want to be in the running to win some fabulous prizes, or to be in the running to win some fabulous, I'm going to reveal it, okay, Daniel? Socks. It's Power BI socks. We're giving away 10 pairs of socks. I know they've been super popular on Twitter and online, so we decided to give 10 pairs to people that will go and have already registered and will comment in the description below, in the link below. So use that, comment about our show, and we'll randomly select 10 people and you'll get some Power BI socks that you can show off. Woohoo. Okay, what's up in Power BI? So we've got our giveaways done. We've got some stuff coming up in Power BI, which is Power BI Dev Camp on May 26. Dev Camp is at 11 a.m. Pacific time, and the amazing Ted Patterson has been running Dev Camp for almost 18 months. So that's a really deep technical deep dive. So make sure you catch that on May 26, 11 a.m. And I think the link is in the description below. I always do this, but I never know, how far I can do this. So anyhow, thanks, Daniel. I hope I didn't go over that. Also, we have Build, Microsoft Build. So if you haven't registered, please go ahead and register. Build is fantastic. You're going to learn so much about all of the stuff that's coming up in the future. It's one of my favorite Microsoft events. So we're really looking forward to that event, and make sure you go register and join a couple of sessions and hear about the great stuff coming up. Okay, in today's show, we are responding to your great feedback about data modeling. And I think, with the growth of Power BI, there's a lot of people who've been using it for a while and they kind of know what data modeling is, but there are a lot of people who are newer to Power BI. And, we wanted to give everyone a bit of a refresher because we've been getting a lot of feedback about, hey, what's data modeling? What do we do? What are the best practices? And so we reached out to the Power BI product team, and they said that we could talk with the amazing Jeroen Heerdt, and he is a program manager with the Power BI product team, and he owns the DAX and the data modeling feature. And Jeroen is also known as Jay. So if you can't pronounce his name, I'm trying to. I hope I didn't butcher it. Please, refer to him as Jay. So Jay's going to talk to us about the importance of data modeling, give us a couple of examples, what we should think about as we're putting our data models together. Jay, are you there?
I am. Hello.
Good morning. How are you?
Good morning. I am good. And you?
Good. Thank you so much for joining us today. It's great to see you.
I'm so excited to be here. So thanks for having me.
Oh, no, it's our pleasure. I mean, I love that the Power BI product team always listens to their community and that we're responding this way. And what a great way to do it, right? And people can comment in the chat. You're going to be answering questions today too, yeah?
Yeah, absolutely. I mean, this will be more of an intermediate level discussion just to make sure that everybody's on the same page. But if you have specific questions, feel free to put them in the chat, and then hopefully our great producers will line them up for us so we can answer them. And then we can take it from there. Yeah.
Okay. So Jay, why don't we start with, tell us a little bit about yourself. I know you're a program manager at Microsoft. I know that you've done some exceptional work, but that's just normal in the Power BI team anyway. But just give us a bit of an intro. Who's Jay?
Well, who's Jay? I'm originally from the Netherlands. I'm with Microsoft for almost 15 years. I joined the product group 2 years ago, a little over now. I've always been working on the data and BI space, and Power BI is just like the tool that I love. And it's just so exciting for me to just be part of the product group now. And, I'm very outspoken. I have a lot of opinions. And then somebody said a while ago, like, hey, if you're so opinionated about Power BI, why don't you come over and do it yourself? Like, you can see how hard it is. So here I am. And so I'm the owner of the data modeling and DAX space. And so that's basically like the thing that I'm most passionate about. But you'll see me being passionate about data visualization and specifically pie charts a lot. But that's not the topic for today.
Actually, I do want to ask about pie charts. I know that there's like either you love pie charts or you don't.
Right.
Which camp are you in? Are you in
I'm absolutely in the don't. Actually, you could put me in the extreme side of don't, like hate.
Okay. All right. Well, then we know that. It'd be great to take a vote in the community actually one day. We should do that maybe for next show or the upcoming ones and do a little giveaway,
I don't know if you know this, but ever since I kind of became the owner of the official blog for Power BI, there has been no pie charts in the feature announcements. None. I force my colleagues to not use pie charts in the screenshots.
And you know what? I remember you also. We also have the poll, right? That you started because we listened to the community, and the community said, "Well, can we just vote on our favorite feature?" And so I think you and I worked with it. Well, it's been up there for now 5 or 6 months. So if you go to community.powerbi.com and you look under the carousel, you'll see, vote on your favorite feature. Is that that's right? Yeah.
Yeah, absolutely. Yeah. And it's a great way for us to get like feedback, and we kind of use it as like. Almost like a it's not like a prize or whatever, but it's not like a contest, but just keeping tabs on what people like. We're excited about our features, but I, as a PM, am always excited about my own features, and then every other PM, of course, is about their own. But it's just a great way for us to kind of gauge where the community is at. Like, hey, for example, the field parameters from the last update, like we think that's the coolest one, at least. Like I beg to differ. I think the one on the composite models was better, but that's just my feature. So and again, it's not a race, it's not a contest or whatever. It's just a great way for us to kind of gauge like what do people actually like.
Yeah. And I would
encourage to vote there.
Yeah, and we grew the product like that by listening, so it's awesome. Yeah. Okay, so you own the data modeling section. You own the DAX area. we implemented the poll, so we're listening to the community a little bit more. And today you're here to answer, well, to run us through kind of the basics, 101, I should say, of the importance of data modeling. And then you're here to answer questions. So why don't we get started? So tell me, why is data modeling so important?
Right. So data modeling is important because if you build a good data model, not only will your performance of your Power BI report be better, it will be easier to maintain. It will also be easier to consume for your end users. So basically, it's all like, there's all benefits. Yes, you invest a little time into building a good data model, but it will take you way, way further than if you skip that step. So Power BI doesn't stop you from starting and building your first couple of reports without a good data model. And we'll talk about what a good data model is. But if you really want to get everything out of there, if you really want to get to like the professional level, to get the maximum performance, the maximum usability, the ease of use, and while keeping things under control, you need to invest in building a good data model.
Yeah.
And it sounds like it's a waste of effort, but it's not. Like in the long run, it's not a waste of effort. So Power BI assumes you have a data model in place. And with those assumptions, you won't see them in the beginning, but after a little while, you notice like, hey, my performance is going down, or this advanced feature doesn't work. No, it's because that advanced feature assumes you build a good data model. So do I need to say more about the importance? I mean, this is important.
Mm-hmm. And it's also, we've talked about this in the past before a little bit, and we talked about, you don't have to have every single attribute in your data model. You only need the attributes for your report. So,
yes,
and so it doesn't necessarily mean, the bigger the better. And maybe you have to start from having all of the data to see what you have as a landscape, right? And then you can cut down to what you need and improve that efficiency, if you like.
Yes.
Yeah, that's what you were talking
absolutely.
about, I remember before. Yeah.
And you don't have to, like, while you're still in the exploration phase of like, what do I actually need? What is the kind of like the data that I need to answer the business question that I'm trying to answer? Yeah, of course, there is not like the need to go and invest time into building a data model. But once you kind of pass that exploratory phase where you kind of know where you need to go, you understand what data you need, you understand like what are the kind of things, the business questions you need to answer, that's where you need to start investing into building a good data model. And maybe your organization already has a data model, right? And then you can just basically tag along and reuse it. That's also where the composite model feature comes in, where somebody else might have built a data model and you're just like reusing it, which is a great way of making use of your colleagues or whoever's work, right? So, but just the fact that Power BI allows you to go immediately from getting data and cleaning data into visualization, it's great because it's free and it's exploratory. You can explore what you need, but then you really need to take a step back and go like, okay, now I understand what I need. Let me build a good foundation to build my house on, right? Nobody builds a house on loose sand, right? Always when you build a house, you want to invest in the foundation first, because otherwise the house on top can be beautiful, but it will just fall over. Exactly the same for the data model. You won't notice it at the beginning, but if the foundation isn't there, it won't last very long.
Exactly. All right. So what have you got to show us today? And
so I wanted to talk about like where we are in the phase of what we just said, like how do you get from A to B, right? So you gather data, you clean data, then you visualize. And that's what Power BI, of course, is built for, to build like cool visualizations and charts. It's exciting. So it's tempting to, once you loaded data, once you went through the Power Query and data transformation step, to just skip the data modeling step and immediately go into building beautiful reports, right? But that's where I wanted to cover or focus today, is that really that third step, that model step, is where loads of people just skip. And as I said, in the beginning, in the earlier cycles of your solution, you won't feel anything. It will all be fine. Performance will be fine. But once it starts growing, once you yourself as a Power BI user grows, or the business users grow with you, and the questions you're trying to answer grow, the moment you start dabbling in DAX and you start building more advanced DAX, you'll notice that a good data model makes your report faster, makes it easier to use and maintain, makes the DAX writing easier. So basically, whenever you see simple DAX, it means you have a good data model. So the reverse is also true. When you see complicated DAX, your data model is not in order.
I think that's something to reiterate. So when you see simple DAX, you have a great data model.
Yes.
When you see complex DAX, maybe the data model could be improved.
Yeah. Like out of my experience, when working with customers, 95 of the problems that people face with our advanced features like aggregations or calculation groups and DAX can be traced back to not having a good data model.
Okay. Well, so now we've got that first section where, we've got the phases. So gather, clean, model, and visualize. Yeah.
Yep. So basically, when we say about model, then we of course need to get into what is a data model. So as a basis, a data model is actually just a collection of tables and relationships. That's what a data model is. If you don't know what it is, now you know. A data model is nothing else than a bunch of tables and the relationships between them. Without those relationships, there's nothing you can do in Power BI to analyze and compare information. So really the relationships and the way you build those relationships between tables are very important. Now, as we already said, like a good data model is important because it improves understandability, performance, resilience to change. It's easy to maintain, all of that is great. So that now that we know what a data model is, we can talk about what is a good data model. And there's a couple of types of data models out there that you will see. You have a flat table, which is mostly known from an Excel sheet. If you think about an Excel sheet, like one tab in an Excel sheet, that's actually what we call a flat table. It's just one big table of data with columns, and that's it. There's no concept of multiple tables. There's no concept of relationships. Now that is a data model. Simplest form, it's not a good data model, not for Power BI. Power BI wants you to have a different data model to be optimized, to get best performance, to the easiest DAX, for example. Now there's another type of data model that's out there, which is OLTP data models, which you will mostly see in transaction processing systems, like an ERP system or a CRM system or some financial database, right? Relational databases use those schemas. Those are great for transaction processing systems where the amount of queries is high, but the complexity of each query is low. That's not the right data model for Power BI either, because Power BI, the amount of queries is low, but the complexity is huge, right?
Yeah.
So we need a different data model. And that's where the last type of data model comes in, and that's a dimensional model. So a good data model for Power BI is a dimensional model. Okay. Now, there's a couple subtypes here, but that's what it is.
Okay, so then we're seeing the screen where we've got the three tables, if you like, and I'm assuming that they're flat tables. So kind of, we've got a couple of questions. And by the way, if you do want to ask a question, go to community.powerbi. Go to our link in the video description. I'm doing this because I think Daniel's putting that link up there. There we are. So comment for Power BI socks, but we have a couple of questions, which is data modeling equivalent to saying it's the same as PQ/M coding? And well, I don't think it is, but that's, please answer. Yeah.
So basically what you do using PQ and M, you transform your data from individual tables to potentially differently formatted tables. Now, basically, think about like these three tables on the screen here with the little icons on the right. Those three can all be created using Power Query and M, right? But then if you just leave it at that, you'll just have three tables. There's no relationships between them. Power Query and M work on the table level. There's nothing like the relationships. So that's where you need to go into the data modeling tab for the Power BI desktop and build that like relationships between them. And when we say building a data model, we take it a step further than just individual tables and relationships. We also say, let's add measures, let's add hierarchies, let's add KPIs, let's do other interesting stuff that just makes your report better and easier to use. All of that you can't do in Power Query M in that data cleansing step that we just showed, like the second step of that 4 boxes that I had. You can't do those things there. You need to do them in the data modeling phase. So if you skip all of that, you miss out.
Yeah, that's a great delineate. That was a great question, by the way, whoever asked that, because the two together, Power Query and M or PQ and M, And data modeling go hand in hand.
Yeah, exactly. They are just two sides of the same coin, right?
Yeah.
Basically, you prepare your data, you make sure it's clean, and then you load it, and that's where the data modeling kicks in, right? So after you have all your clean, shiny tables loaded, you have your customer list, you have your product list, you have your sales table, great. Then you start building relationships. That's where you add measures, KPIs, hierarchies, et cetera, that's where the data modeling kicks in.
Now, and speaking of KPIs and adding measures and everything, we have another question from the community, which is, does performance decrease if you load less attributes to a model?
I would even say it's a reverse. Like if you load less attributes to a model, the less complex it is, performance will increase, right? So many people are tempted when they are exploring a data set to just load everything, as you already said, and it's a great way of doing that. Just load everything. So I'm still figuring out what is important, what's interesting, what is not important, what don't I need? That's the exploratory phase. But after you understand how this data set works, you have to go back and say, okay, now let me just only add what I actually need for answering my business question. And of course, there's a little bit of wiggle room because sometimes you want to add a little bit more because you're not entirely sure how your business user is going to use that report. You want to give them some flexibility to explore. But in general, the simpler you can keep your data set, so the less attributes you load, in general, there will be better performance. Now, there's a balance there because the more you take out, the less questions you can answer, right? The more you specify for the questions that you expect to get. There's less flexibility for the end user to just go free explore to understand the business problem they're trying to solve, right? So there's a balance to find. In general, if you want to optimize performance and you absolutely fully understand the question that people are going to ask and why they're using your report, and there's no other things they're trying to do, just that thing, then yes, of course, remove everything that's not related to that answering that question and reduce the data set to just the aggregates and the attributes that you need.
Okay, fantastic. All right, so what is a good data model?
That is a good question. So a good data model is then a dimensional model. And a dimensional model consists of three key ingredients. We have two types of tables. We call them facts and dimensions. And then we have something that's not a table. That's a relationship. So all those three things together make a data model. Now, of course, the next question is going to be, but what is a fact, right? What does that even mean when I say fact? So let me give you a very simple example. So let's say, Kelly, we meet each other in the office, and I come to you and I say, hey, I learned so much today about 5. What would be your reaction? You would probably look at me like,
what's 5? 5 what? 5 oranges? 5 cups of coffee?
Exactly. That's the point. So 5 is a fact. I just gave you a number, 5.
Right.
It didn't tell you anything. You asked, okay, 5 what? That's context. So basically, you asked 5 what? So you maybe, let's imagine we're in the company that sells products. So you said 5 what? Did you sell products? Did you talk about people, cows, planes? What? Years? Who knows? And that's where dimension comes in. So basically, a fact is everything that's numerical, anything you want to count, anything you want to sum or do an average or whatever calculation over, that's a fact. And then everything else, which gives context to the fact, is a dimension. Okay. So in a typical business, it would be a product, would be everything you know about a product, like its name, its category, its color, its size. All of those things would be part of your dimension. You're probably, if you're selling products to customers, you're probably tracing something about a customer. Where do they live? Which country? All of that is a dimension. If you're selling products, you probably want to know when you sold something. So time or date actually in itself becomes a dimension. It's not a fact because we're not counting years. We're not counting somebody's age. We're not interested in totaling the total age of our users, maybe the average age. But in essence, it's not a fact. So think about facts as numerical. Think about dimensions as context.
Okay, awesome.
So you end up with two types of tables. You end up with numerical things in a fact. You end up with context in dimensions. And you basically build relationships between those. So that's the third ingredient, to be able to analyze the facts by the context. So without those relationships, there is no way for Power BI to help you analyze when you sold a product, or to whom you sold a product, or even which were the most popular colors that we sold, product colors that we sold to customers from the US in 2022, right? If I want to ask that question, there's loads of relationships going on, because we say, what's the most popular color? So we basically need to count products by color. That's a first relationship, because we need to understand what products we sold. That's one.
Yep.
And then we need to say, oh, to whom did we sell this? That's another relationship that we use. We use a relationship for sales orders to customer. That's another one. And then we also asked a certain time-based filter, like in 2022. That's another relationship that we use. So here, in just asking a very simple question like, what's the most popular color for people buying our products in the US in 2022? We already used one fact, 3 dimensions, and 3 relationships. And that's exactly how a data model works. That is what a data model is. It is the thing that has those information, that numbers, that contextual information, and the relationships that enables you and your user using Power BI to answer those questions.
Awesome. So if anyone has any questions on that, please post them using the link in just below here.
Right.
And we'll be able to answer them. We do have a bunch of them coming through now in the community, but I wanted you to get to the next kind of phase of explaining this before we get to more questions. So, okay, so we've gone through what is a good data model. What's next after that?
Well, let's talk a little bit about how you get from like a typical business process to actually understanding what's a fact and a dimension. I think that would be useful. I think I saw that also in some of the questions there, that, you know, for example, if you take a very simple invoice, right? So I have an invoice here on the left. You might be looking at it and go like, but what's the dimension and what is the fact in here, right? And normally you build such a data model, a dimensional data model with facts and dimensions, around a certain business process in mind. And in this case, for example, it's a sales process. We sold products, right? So here, the numerical information, like the unit price, is our fact. The fact that we sold something, the number about that, like 8.99 and 21.98, those are numerical things. That's our fact. And then everything else, like description, which is a product description, is a dimension. So now we end up with a sales table and we have a product dimension. There's no relationship between those, but that's what we have today, right? And then you can also see that this invoice happened on a certain date. Hey, that's another key, that there is an actual construct like date that's interesting to analyze this data. Then you also see that we sold it to somebody. Hey, that's a customer. They live somewhere. We have information about them. That's another piece of context that we have. There might be taxes that we have to include as well. So basically, this is a very simple business example of a business process in which you then can slowly transform that into a data model. And let me just jump ahead a little bit. But you can see that here's an example final data model for that process. And of course, it's not optimized, and there's loads of things you can improve. But as a basis starting point, as you can see here, I have a sales table in the middle, which is our fact. We have a product amount. We have an order quantity. And then we have relationships around it. We have dimensions around it, where we have a product, a date, and a customer. And all those things were part of our original business process that we just looked at on the invoice, right? So basically, by looking at the business process you're working on, you can kind of paint a picture of what this model should look like for you. Now, this brings me into an important topic, because this is normally called a star schema. And it's called a star schema because the fact is in the middle, then everything else hangs around it, which is the dimensions. Like, it's almost like a star. If you squint a little, imagine a couple more dimensions, you end up with like a 5 or 6 star,
Yeah.
right?
Yeah.
That's a star schema. So if you start looking at the literature, loads of people are saying, oh, you need a star schema to work with Power BI. They're right. the star schema is just a type of dimensional model. So just to kind of like help you understand how this business process maps into your actual data model, right? So the fact here is sales. That contains only numerical information, and then all the context information for product, for date, and customer is stored in the other tables. So with this in hand, I can now go and answer that question, for example, about, what's the most popular product in the US in 2022? Because I can count how many times a product was sold. I can slice that by where customers live, and I can also slice that by when the product was sold using a date dimension. So now we can answer the business question, which is great. So this is like the basic introduction into how you do dimensional modeling. Now, of course, getting here is not easy. There's no algorithm. There's no stepwise recipe you can take. It's almost like magic, and that's why loads of business consultants exist, like business intelligence consultants exist, that do this work, that build a data model for you. But this is worthwhile investment to do this, because it will make your life easier down the line.
We have a couple. Thank you so much, Jay, because I think it's super important. This visual, it's great. It's a simple example, but I mean, all of your data starts like this way. And we have a couple of questions about tables, and it's how many tables to break my fact table into? And
So that's a good question. It's really dependent on the type of business problem that you're trying to solve. But for example, if you have, I see loads of people going like, oh, so my sales from 2019 and my sales from 2020 and my sales from 2021 are all separate fact tables. And that's not the right approach. That would be one big fact table, because the thing you want to track about your sales hasn't changed, right?
Yeah.
You still sell products to customers. That hasn't changed over the years, probably. So the only thing you need to do here is mash them together to one big fact table and then say, what's different between those three tables that I just mashed together? It's time. So if you don't have time as a dimension yet, add it, and then you end up in this kind of scenario where your big fact table with sales over years is actually now just one fact table instead of separate, slightly different ones. Now, if your business problem is different, for example, you might be tracking sales, but you might also be tracking inventory. Now, inventory, if you think about an inventory process, it's not about selling. It's basically, what do we have in the warehouse? So there is no customer, right? Because at that point, when you track if a product is in your warehouse or not, nobody has bought it yet. So there's no customer relationship. Customer is not involved. But time is still involved, because you want to know when the product was in stock, how much you had at that time. So time is still an interesting dimension. Product, of course, is an interesting dimension, because that's what you're tracking.
Yep.
And this maybe, if you have multiple warehouses, might be a different dimension that we haven't talked about, which might be warehouse or storage or whatever.
Location.
Right? Yeah, location, exactly.
Yep.
So now these two, imagine a data model where I'm tracking both the selling of a product and the inventory. These two things now cannot be in the same table, because they're not sharing all of the dimensions, right? So product and date are shared, but customer is not, because inventory doesn't have to do anything with customer. And then location of where it's stored in the warehouse presumably doesn't have anything to do with sales. So now you end up in what we call a galaxy scheme, which is a term for a data model that has more than one facts. So now we have two fact tables. We have inventory and sales, each with their own relationships, each with their own dimensional models. We just love the galaxy and the stars, I guess, over in the data modeling world.
I think it makes it easy to kind of picture it, right? Because, a star,
A star is just a single thing with the things around it. And now we have multiple stars. So what is multiple stars? It's a galaxy.
Galaxy, yeah.
You could also have called it the Milky Way, but yeah.
You can kind of see that behind me here. It's actually sequence, but it kind of looks like the galaxy, right?
Yeah, exactly. So there's like a little subtext there. It's like you were prepared for that. You did this on purpose for this call, right?
Yeah. And exactly, all for you. All for data modeling. We
Right,
do have we have a question about the fact table, which says, any good resources for, do you have any good resources if your main is a factless fact table, or do the same principles apply regardless?
Yeah, so that's a good point, right? Sometimes there's nothing you want to track for
Okay.
just a fact. The only thing you want to track is the actual relationships of things together. And that's what you end up in a factless fact table.
So
It basically means, for example,
So
let's say
are we doing, and I'm sorry, are we doing so then rather than track, we're building a report so we can display what we have.
right. So
Okay.
think about the following. Let's say you're in some kind of educational system, right? And the fact that somebody took a test is what you're interested in, not the results, not if they passed or not. That's not what you're interested in. You're just trying to answer the question, who did take what test at what time? That's a factless fact, because there's nothing you're doing here. There's no number, there's no sales, there's no mark. You're not interested in all of that. The only thing that we're tracking is student J or student Kelly took test ABC on this date. Again, the data model would be something like date, right?
Yep.
That's our dimension. Test, another dimension. Student, another dimension. And then something in the middle that brings all these things together. That's what we call a factless fact. So in the middle, you will still have your star schema, but that star schema won't in itself contain any numerical information. There's only the relationships coming together in the middle there that will allow you to answer the business question. Now, this is a bit of a fabricated scenario because, to be honest, most of the times, those education systems, they are not only interested in understanding if Kelly took the test, right? They also want to know what was the grade. So with that, your factless facts actually turns into a fact table, because now you have something that you can track. What's the grade? Did you pass or not? Yes or no? That's something that you can count. How many times did you pass? How many times did you fail that test? Those things are now countable numbers. That's a fact. So now we have transformed our factless fact into a fact table. So there's lots of fact and factless things in there. But basically, to answer the question, if you really have a business scenario where a factless fact table is nothing else you need to track, you still need a star schema.
Okay, so we have another question about the dimensions, and funny that you should say that, because we have a question saying, must the data in all dimension tables be unique or not? And that's a really interesting one, right? Because I'll let you go and answer that one, because I have a case where it's not always the way.
No, right, and that's a good point. And there's multiple ways I can take this and answer this. But in general, the rule of thumb is that your dimension information needs to be unique on the things that relate to my fact. So here's where we get into relationships. So the lines between these tables on the screen here is what we call the relationships. And normally you want to get to the point where there's what we call a one-to-many relationship between a dimension and a fact. So you see the lines going, right? Yep. The vertical and horizontal lines, they are one-to-many. It means...
Can we zoom in on that a little bit, please, Daniel? So there's a number 1 between the product and the sales table, exactly. And then there's an asterisk there, right?
Yes.
And an
arrow. This means that there's one product and many sales. And this makes total sense, because as a manufacturer of, let's say, I don't know, bikes, hopefully you won't sell each product only once. Hopefully you make loads of red bikes and you sell loads of red bikes. But the product itself, the bike, is just one thing. Mm-hmm. So that's where you end up in a one-to-many relationship. The one product is being sold to multiple customers multiple times in multiple years, for example. However, it's not a one-to-one relationship, because if you only can sell that bike once and you never produce another red bike, then it would be a one-to-one relationship, because you only can sell it once and then it disappears. So that's what a one-to-many relationship is. In most situations, that's the relationship you end up in. Now, this means that the list of products over in the product dimension is unique, right? That red bike, one certain red bike with a certain tire, sort, and mountain bike or city bike, number of gears, blah, 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 blah. That thing is a unique product. That thing by itself is only listed once in that product table. It's never listed multiple times.
Okay.
It does have multiple times that's being sold. So the number, the unique identifier for that product, let's call this our first product, product 1. That product 1 is, that number will be only shown once in the product table. A second product will be called product 2. And then over in the sales table, we'll see 1 showing up more times, because hopefully we sold this product more than once. And that's how these relationships work. So basically it means that in the product table, there's only one product 1.
Yep.
Now, this doesn't mean that all of the data in the dimension table must be unique. And I think that's what this question is really about.
Yes.
It basically means that all of the keys, as we say, the things that define the relationship between the product and the sales, must be unique over on the product side.
Right.
So that product number 1 can only appear once. However, there's probably multiple products that are red, right? Product number 1 might be red. Product might be 2 might be red. Product might be 3 might be red. Maybe we only make red products. Who knows? For whatever weird reason.
Because it's a fire engine factory.
For example. So then, if you track the color for the product, then the word red might appear multiple times. And that's totally okay. And in fact, the data modeling engine, the thing that make Power BI run, actually likes the fact that there's data duplication. And this is counterintuitive to many database people.
Yeah.
Especially if you come from like a database systems administrator world, you are trained. I was trained the same way, by the way. I distinctly remember my first job that I said to people like, this is not a good data model. And they were building a BI system, an analytics system. And I told them, this is a wrong data model, because university told me you should never have any data duplication. And they said, okay, you make our reports run on what you think is a good data model. And of course they were right. The reports didn't run properly because the performance was horrible, because these type of analytical systems want data duplication. That's how they work. So that color red will be apparent multiple times.
And it's super interesting, because I think, database modeling before, it's very much of a row context, if you like. That was kind of old school. But Power BI has a columnar
exactly
context, and it allows that relationship building. It's a lot more efficient and allows the manipulation of data so much better. And I think making that switch, especially if you're used to working with just your basic Excel, is tough for people. But if you're used to using pivot tables, you kind of understand the it's not directly the same thing, but it's similar, and you kind of understand how those relationships can be formed. And exactly. That's why you have that duplication. It's super important, sometimes.
So I just wanted to get to the bottom of that with the relationship type. So the moment you see one-to-many relationships in your data model, so once you go into your Power BI modeling view and you see those tables with the relationships between them, if you see 1 and star on both sides, that's great. That's a sign of a good data model. The moment you see 1 and 1, it's still okay, but it's something that you might have to reconsider, because one-to-one basically means every product is only sold once, or there's an individual record, an individual unique thing on the one side of the relationship, and then the other side, it only happens once. There's no plural on any of the other sides. In those cases, maybe you just need to put them all together into one dimension, because it's just kind of useless to have this. Sometimes it's the thing you need, but most of the times it's not. You want to get to the one-to-many. Then the other thing to look out for is if you have many-to-manys. So if you have many-to-many relationships, it basically means there's no unique side of the relationship. And Power BI really doesn't like this, to be honest. So you should try to avoid it. But sometimes you can't, because if you go back to the school system again, let's say I'm tracking courses and I'm tracking students. Hopefully, there's more than one student in each course. Otherwise, the room would be very empty. But reversely, hopefully, each student also takes multiple courses, right? Otherwise, it's very bad for business, right? If every student just comes in and takes one course and then disappears.
Yeah.
So here, if you build a relationship between a course and a student, you'll have a many-to-many relationship because, Kelly took multiple courses, and while she was taking those courses, there was another student called Jay in the same courses. So that's a many-to-many relationship. Those happen, and it's okay. But if you see a data model that has primarily either one-to-ones or many-to-manys, that's a sign of not a good data model. You want to have 90, 90% of your relationships should be one-to-many, and then maybe a one-to-one, maybe a many-to-many sprinkled in, but really you want to avoid those. So that's basically the types of relationships you will see. They are easily recognized because one-to-many shows us 1 and star, one-to-one shows us 1 and 1, and many-to-many shows us star and star on the edge of the lines.
It's super interesting because I find that the many-to-many I use if I'm putting two data sets together. So, for example, a 2022 list of students for that year, and maybe the same students came back the next year, but maybe we have the same number, but we don't have the same students. So maybe some we do, some we don't. And then what I like to do, and we'll do this for another show, is I like to combine that, unpivot, and use a date dimension, and then change the way that I look at that data, because if I do a many-to-many, I'll lose some of those numbers and I'll lose some of those relationships. So many-to-many are something to maybe proceed with caution, right? I would say.
Absolutely.
Would you? Yeah, you agree?
Yeah. And actually, is a little tidbit for you is that if you leave the many-to-many in the data model, what Power BI actually does under the covers, we store it as 2 one-to-manys. So what we do in the engine, we actually look at the many-to-many and go like, okay, that's great that you leave it like that, but we don't really like this. So we'll just generate what we call a bridge table, which we put in the middle. You won't see it, but we'll put it in the middle, and any many-to-many can be expanded into 2 one-to-manys and a bridge table. So let's say we have students and courses, right? That's a many-to-many. If you do that, what Power BI will actually do is we'll put a table in the middle, which is student courses, and we'll just record in that Kelly took this course and Jay also took the course, and that that course as a result had both Jay and Kelly in it, right? With that bridge table that we generate for you, we can then store your many-to-many as 2 many-to-manys coming in. One from students to that bridge table and one from courses to the bridge table.
That makes total sense.
So that's what we do under the covers. With saying that, we actually would like you to just do that on your own.
With the one-to-many relationships, they are the better ones, right, to go with.
Yeah, exactly.
They work better.
And Power BI will do it for you, but in many cases, it just makes more sense to do it on your own. Because it's also like, you're in control. You know exactly what's happening. If there's any mistakes that we make because we try to be smart, you can capture that. You can make sure that that's like exactly behaving as you want it to do. So whenever you see a many-to-many, please consider breaking them out in a bridge table or rethinking your data modeling. Okay,
there's some great tips. So any other information that you can share about data modeling?
Well, there's
I know you could go on forever, right? I think we've got another few more minutes. We can go for another 5 minutes, I think.
Yeah, no. So I really wanted to focus on one more thing, and we kind of touched upon it a little bit in the beginning about like the different types of data models. We see so many people that skip the steps of creating a good data model, and they just go in and they go like, oh, Power BI is here. I just installed it, and I have my Excel file, and I've got this database connection. Great, I'll just put it in and just go and build my visualizations. Awesome. They skip the data modeling step. So basically, we see a couple like types of data models, and you will see the same. We see flat tables, which are mostly like CSV files or Excel files. You see normalized, which are coming from ERP or CRM systems. Those work great for those, but not for analytical systems. Now, Power BI will happily work with those in the beginning, but once you get more advanced, you start writing DAX, you'll notice that writing a DAX statement over a normalized or a flat table is really hard. Power BI assumes you have one of the other two, which is a dimensional model. A star, and I didn't mention a snowflake yet, but basically a snowflake is a star, a fact in the middle, dimensions around it, but now we can also have other dimensions hanging off of dimensions. So now we go from a star to a snowflake. The moment you have multiple facts, you go into a galaxy. I don't know why we went from like star to galaxies and then figure out some other term for snowflake. We should really have like solar system or something else for snowflake, I think. But anyway, to just keep it with the star theme, right? So that's basically the 4 types. So you will see them here as a summary. You'll see flat tables mostly in like, it's not really for any database, it's mostly file-based. Normalized schemas you'll see for CRM systems, relational databases. They work great for that type of application because that type of application has many high volume, low complexity queries. And then the other 2 types, the star schemas and the snowflakes, the dimensional types, those are actually built for low volume, high complexity queries. And it turns out that the type of questions, the type of queries that Power BI generates when people want to answer business questions are highly complicated. So that's why you should invest in data modeling. You should build a star schema or a snowflake. Trust me, you'll get the best out of Power BI. If you do that, don't shoot yourself in the foot and stick with the flat table nor the normalized thing. Trust me, you will just hurt if you don't invest into a good data model along the line. So your DAX becomes easier, your performance is better, it's easier to maintain, it's easier to work with, it's all positives if you could build a good data model.
I love this table. It really helps people, especially if you're new or if you're doing a refresher. You could be kind of developing Power BI for a couple of years and then, I'm going to go back to my data modeling. I'm going to go and have a look. And, sometimes you have to refresh your data model. You have to review it because the source may have changed or, we have more attributes or there's name changes. I mean, there's always something to review. So either when you're creating your new data model or reviewing your existing data model, it's all really good best practices. And it's great to have that lookup table to say, okay, well, if I'm doing this, it's fantastic. I love that you put that together. Thank you for that.
Sure. No worries.
Yeah. And we have another question about, here we go. I'm just reading that here. Would you get incorrect numbers if using many-to-many relationships? And I think we already said, you're not going to get incorrect if you kind of use the many-to-many relationships.
Performance will be less good.
Oh, really? Okay, I didn't know that. So
so
it slows performance?
Yeah, there's like when we have many-to-one relationships, when you have many-to-many relationships, what we do in the engine, we just split them out into 2 things. We build a bridge table, we keep doing it. So it's an extra work that we do while we try to answer the questions that you ask to the database through the visuals, right? So you build a bar chart, you put like students and courses in there. This engine to answer that has to look at, does that bridge table already exist? If not, let's create it. Mm-hmm. Is it up to date? If not, let's update it. So there's loads of extra work going on. So you will get the right results. And of course, I mean, if your data set is like a couple thousand rows or even a couple million rows, you probably will not even feel the difference. It's like in the level of milliseconds that the difference is. But if you grow into like the multi-million or even way like hundreds of millions of rows, then suddenly that milliseconds turns into a second or 2 seconds. And now you have your business users that go like, hey, but if I do this, then suddenly your report is very slow. Mm-hmm. Yes, that's because you use the many-to-many.
And that's when you start using Synapse.
For example,
putting my plug in there for Power BI, Synapse Analytics. You've got to
right, exactly. That's where you might want to jump into something like Synapse, or it's probably redesign your data model into a one-to-many. So no, a many-to-many won't give you the wrong results. will give you the right results, unless you did really weird things. But in general, we will give you the right results. However, it's just a performance and usability thing that's very important.
Awesome. Okay, so I know that we were talking about build earlier. So firstly, thank you so much for all of this information.
No
we
worries.
mentioned to the audience that Microsoft Build is I think it's tomorrow, right?
Yes,
And
exactly.
so we have to register for that first.
Yep.
And that's the link below here. And then also tell us about Build and Power BI. Are there anything that we should know there? Like, I know we've got some announcements. We can't say anything today. I get it.
No.
Not that I know them all, by the way. I'm not that important. So talk to us about Build and Power BI a little bit.
Yeah, I mean, Build is just exciting time, right? As you said in the beginning, it's like one of the biggest conferences that we have, and it's just one where we focus more on like the technical side of things, less on maybe the like end user side of things.
Okay.
And for me, as a data modeling and DAX person, that's like where my core work is, right? I focus on the data side, not so much on visuals. I have opinions on visuals as pie charts, but I put
you have very strong opinions on pie charts.
Yes, of course. But on the core side, on the technical side, that's where I live, right? That's where my area is. So it's a really exciting time that Build is now here. Now, one of the features that I've been working on for the last, more than 2 years now, is the composite models on Power BI data sets and Azure Analysis Services. And we've seen many people wanting to build a good composite data model on analysis services, not Azure Analysis Services, no, SQL Server Analysis Services, the one that you can run and install in your own data center if you don't use Azure. That thing is not available today. That ability to pull data from that database and then add more data, which is what a composite is, right? Do you know what a composite is, Kelly?
Yeah.
Okay. So a composite is basically two things, right? Basically two things together.
Yep.
I always like to say about glues. The glue that you buy in the big box store, right? The strong glues, they come into two components. They're not glue on their own. But
like the epoxy, right? You have you need both, right?
Yeah, and that's what a composite is. It becomes more value if you add the two together. So that's what a composite is. The ability to you cannot do that today with data that's stored in SQL Server Analysis Services. Now, I'm not allowed to say anything, but I would pay very close attention to the Build keynote tomorrow. And the announcements that we're going to make, because something is going to happen.
So Build keynote tomorrow.
Yes.
Build keynote. Okay. And we're going to have some great announcements that'll help us do more with Power BI, with our data.
Oh, yeah. Especially if you work in the data modeling space and the composite models. You've been waiting for this. You've been asking me for the last 2 years, like when is this coming?
Are we going to get this? Okay, yes. So we're going to look at the keynote tomorrow for Power BI for this data modeling thing. Okay, this is going to be super. This is going to be super interesting. And so, I actually don't know what it is. So I'll be watching tomorrow. So, we got to do that.
Just stay tuned. Watch the keynote. Watch the opening sessions tomorrow morning. Also, look at the blog. We'll blog about it, of course, when it launches. So it's going to be an exciting time.
Awesome. So, okay, that's very exciting. I'm very, very happy now. I think that's going to be super cool. All right. So now that we've got I think we've answered all of these questions. I really want to say thank you for joining us today. And if anybody has any more questions, we do have the link here, which is AKA Power BI Show comment. Please go and comment. And Jay, are you going to be looking at those comments and going through and seeing if you can answer some questions today?
Yeah, absolutely. Later today. I see a couple in there. I don't see too many though. I see a couple. I think most of the people comment on YouTube, which is great, because it's really hard for us to go back to that and answer that, right? The YouTube chat closes after the session, which is
it's super hard actually. And when we're giving away socks, everyone, it's best to to comment in the community, because then we have a way of contacting you. When you comment in YouTube, we just found out, we've only been doing, I think this is our 5th episode, right, Daniel?
Right.
And so, we're going back and Natalie and Eileen are saying, we can't find this person. We can't find this person. And so that's kind of why we started that comment in the community. So then we can at least have an opportunity to select you and then be able to contact you.
Yes.
So, yeah, because we really want to be able to give you some socks or whatever else we're giving away.
And the YouTube chat, I mean, I know there's more questions in there.
Yeah.
That closes after this session closes. I cannot go in as a speaker, and I cannot go in and afterwards go type and answer your questions. So it's great while the video is running and while we're doing this live stream, but afterwards I cannot go back to that. So really, if you, and that's an invitation to everybody that's watching now, like if you have something that we didn't get to, or you want to get your questions answered, you want me to look at it, either go find me on social media, or please, and I think that's even better, leave that comment on that link that was just there, because then not only I can take a look at it and I can try to answer your question, but you'll also be in the running for socks. I mean, who doesn't want Power BI socks, right?
Exactly.
So if you're now sitting in the YouTube chat and go like, they didn't answer my question, they didn't get to it, and now it will be lost forever. Go to this link, leave the comment there. I'll promise you, I'll take a look at it. And you might be in the running for socks. So,
and you might be in the running for socks. Yep. And today it's cold. It's sweater weather today in Seattle. So you definitely need your socks to keep those toes warm. And, I think it'll be great for people to comment and have their questions answered. That's more important. Socks are second, but, hey, everyone loves their socks. We also have a bunch of resources, right, that you put in the chat below. And are we putting those on the community as well, Daniel?
Yep, those resources should be on our community gallery link, which is this link below, and then as well as on the YouTube channel. So thank you, Jay, for you gave us some webinar information, data modeling webinar, a Learn module, as well as your social media links. They should all be there in the community and on YouTube.
Exactly. All right, so we've got a couple of last minute reminders. Stay here with us, Jay. Sure. Number one, go and comment on the PBI show comment for answers to data modeling, the importance of data modeling. And then number two, don't forget to register for MS Build, for Microsoft Build. Number three, remember TED's Dev Camp on May 26th at 11 a.m. Pacific. That's a technical deep dive. You're going to love it, those developers out there. And then what else? That was three. Number four, join us at community.powerbi.com. And I think that's about it for today. Thank you again for joining us, Jay. Really, really enjoyed this session.
Thanks for having me. I enjoyed it as well. I'm happy to, work with you in the community. I just, can I say something about how amazing it is that people are in the community? It just, as a person working on the product, rest assured that you being active part of the community is the reason we go work on this and build the most amazing thing in the world. You are the reason, not like some other driver. The fact that I as a person with my work am able to help you and everybody else in the world that uses Power BI, that's the reason we work. So without you in the community, there's no magic like this.
Exactly. I love it. I can't agree with you more on that. I'm kind of on the fence on the pie chart thing, but absolutely agree with you on the community. Absolutely.
That's okay. We can talk about it later. No worries.
All right then. Okay, so that is the end of our show. Thank you so much again for joining us. We really appreciate the time that you spend, because you can spend your time anywhere and you chose to spend it with us here with your Power BI community. Okay, have a great week. Bye for now, and we'll see you, or we'll meet you in the community.